In this pipelining concept, let us discuss about this pipelining concept. This pipelining organizes the execution of the multiple instructions simultaneously. Pipelining improves the throughput of the system. That is, in pipelining, the instruction is divided into subtasks. Each subtask performs the dedicated task. The instruction is divided into 5 subtasks: instruction fetch, instruction decode, operand fetch, instruction execution, and operand store. The instruction fetch subtask will only perform the instruction fetching operation. The instruction decode subtask will only be decoding the fetched instruction, and so on the other task will do. So the instruction in a process is divided into 5 tasks like this. Yes, that is the instruction fetch, instruction decode, operand fetch, instruction execute, and operand store. In the first subtask, the instruction is fetched. In the second, the fetched instruction is decoded. In the third, the operands of the instructions are fetched. In the fourth, the arithmetic and logical operations are performed on the operands to execute the instruction. In the fifth stage, the result is stored in memory. These are the that is, the instruction in a process is divided into these 5 subtasks like this. They are instruction fetch, instruction decode, operand fetch, instruction execute, and also the operand store. Now we'll look at this figure which is given below. The 5 instructions are pipelined. That is, the first instruction gets the completed in 5 clock cycles. After the completion of the first instruction, in every new clock cycle, a new instruction completes its execution. Here, that is, this diagram will shows this pipelining of 5 instructions. That is, here we observe that when the instruction fetch operand of the first instruction is completed in the next clock cycle, the instruction fetch of second instruction gets started. This way, the hardware that is always, that is, never that is, this way the hardware never sits idle. That is, it is always busy in performing some or other operations. But no 2 instructions can execute their same storage at the same clock cycle. Next, the types of pipelining. That is, pipelining processes depending upon their functionality are classified into arithmetic pipelining, this instruction pipelining, this processor pipelining, and also multifunction pipelining, dynamic pipelining, scalar is vector pipelining. So the first one is, that is, in this type of pipelining, this one scientist, that is in the year 1977, Handler and Ramamurthy classified these pipeline processes depending on their functionality. So the first one is arithmetic pipelining. In this arithmetic pipelining is designed to perform high-speed floating point addition, multiplication, and division. Here, the multiple arithmetic logic units are built into the system to perform the parallel arithmetic computation in various data formats. So, some of the examples of this arithmetic pipelined processors are star 100, Cray 1, Cyber 205. All these are arithmetic pipelines. The second one is instruction pipelining. In this instruction pipelining, here the number of instructions are pipelined and the execution of current instruction is overlapped by the execution of the subsequent instruction. So it is instruction, it is also called instruction look ahead. So instruction pipeline is also called as instruction pipeline look ahead. So in this instruction pipelining, a number of instructions are pipelined and the execution of the current instruction is overlapped by the execution of this subsequent instruction. Next one is processor pipelining. In this processor pipelining, the processes are pipelined to process the same data stream. That is, the data stream is processed by the first processor and the result is stored in the memory block. The result in the memory blocks is accessed by the second processor. The second processor reprocesses this result obtained by the first processor and the redefined result to the third processor and so on. So these are about this processor pipelining. And also the next one is multifunction pipelining or unifunction. That is, in this multifunction pipelining, the pipelining performs the precise function every time is unifunctional pipelining. On the other hand, that is, this pipelining perform multiple functions at a different time or multiple functions at the same time is multifunction pipelining. The next one is dynamic pipelining. So in this dynamic pipelining, static or dynamic pipelining, the static pipeline performs a fixed function each time. That is, the static pipeline is unifunctional. So the static pipeline executes the same type of instructions continuously. Frequent change in the type of instructions may vary the performance of the pipelining. Also, dynamic pipelining performs several functions simultaneously. It is a multifunction pipelining. So, this is about this dynamic pipelining. And also, the next one is this vector pipelining. That is, the scalarized vector pipelining. Scalar pipelining processes the instruction with scalar operands, but this vector pipeline processes the instruction with vector operands. So these are about the different types of pipelining. So the pipelines are which are classified into arithmetic pipelining, instruction pipelining, and also this processor pipelining. This unifunction is multifunction pipelining, and also static ways, dynamic pipelining, the scalar is vector pipelining. So these are some of the classifications of this pipelining. Okay, these are about the concept of this. These are about the pipelining concept. Okay, thank you.